Hi everyone, I hope you're having a fabulous day. Today in this lesson we want to have a look at a topic which often causes people a little bit of confusion, multiplying decimals. So this is something that can often seem quite tricky and a little bit foreboding because you're thinking, what on earth do I do with all of these decimal points? However, there are some tips and tricks that we can use in order to make this a little bit easier for everyone. So just as a reminder, before we get into doing this multiplication, let's think about what a decimal actually is. When I talk about a decimal, it's just another way of saying part of a whole number, in exactly the same way as I might say 1/2, or 1/4, or 1/3, or 1/326th. All I mean is that in one whole number, I've split that up into smaller parts. We use decimal numbers as a way of talking about these fractions or parts of a whole because they fit in much better with our place value system, which increases numbers or splits them into smaller parts by multiplying by 10 or by dividing or splitting them up by 10. So for instance, if I have 0.5 as a decimal, what I mean is that I have split a whole number into tenths or into 10 parts, and I have 5 of them. If I have 0.25 as a decimal, what I mean is that out of my one whole number, I've split that up into tenths and hundredths, and out of those tenths and hundredths, I have 2 tenths and I have 5 hundredths. We might express these as fractions by saying 5 tenths or 25 hundredths, or indeed 1/2 and 1/4 if we simplify those down. Okay. Now, when I multiply a decimal, what I'm essentially doing as a result of that is saying I want to find a part of a whole number, or indeed another decimal number, that I am multiplying it by. This might sound a bit confusing, but it's essentially the same as if I say something like, I want to find 1/2 of this number, or I want to add together a number of halves. Okay, so if I look at my first example at the top here, 0.5 multiplied by 6, if I was to write that out, what I technically mean is 0.5 plus 0.5, etc., 6 times over. And if I add all of those 0.5s together, I get the number 3. This is one way of thinking about it. Another way that I might think about this multiplication is by saying find 0.5 of 6. If I remember that 0.5 is 1/2, what I actually mean by that is saying find 1/2 of 6. All of you know how to find half of something. I just divide it by 2. Okay, so it's just a different way of thinking about how I find parts of a whole number or parts of another number. What you might notice when I've done this multiplication here is that my result, 3, is actually smaller than 6, but which sounds like it shouldn't be correct because we're used to thinking of multiplication as making a number bigger. Remember, if I multiply by a decimal, all I mean is say find part of this number. So it's perfectly okay for this answer and expected for this answer to end up as being smaller than 6, as an example. If I've got something a little bit more complicated, like 0.8 multiplied by 1/2, what I might want to do here is think about, well, if this is the case, then I'm going to have to do something slightly different. There is a really useful tip that we can use, which is to turn the decimal into whole numbers, do my multiplication as normal, but then reduce the number again at the end. So as an example, if I do 0.8, which would go over here, if I write it into my place value column, I can see that if I multiply 8 by 10 by doing one jump on the place value column, I can turn that into the number 8. So if I do 0.8 times 10, I'm going to get the whole number 8. The same thing happens with 1.2. If I write my 1.2 in here, so 1 in the ones column and 2 in the tenths column, and multiply this by 10, doing one jump over, I'm going to get the number 1.2. It turned into 12. So this is a lot easier to work with because I know how to do 8 times 12. That's just part of my standard multiplication tables, 96. Now, because I've increased 0.8 by 10, I've multiplied it by 10, I'm going to have to divide 96 by 10. So going off in the other direction, I'm going to make that 10 times smaller. If I put that into my place value table up the top here and move it along, I can see that that's going to end up with my 9 in the ones column and my 6 in the tenths column. Putting in my decimal point, I get 9.6. But I also increased 1.2 by 10. I multiplied that by 10 to get the 12. So I've got to divide by 10 a second time. So I get 9.6, and I'm now going to divide this by 10. So I'd end up with my 9 in the tenths column and my 6 in the hundredths column, meaning that my answer will be 0.96. Okay, and this does look to some people like it should be too small, but if you think about it, we know multiplying by decimals that it's going to end up somewhere in the middle of the two numbers that I've been given, somewhere between 0.8 and 1.2. And this value, 9.6, does fulfill that criteria. Okay, so the key tip that we can use is that when I'm multiplying decimals, turn my decimals into a whole number, do a nice easy multiplication, and then divide the result by the number of tens or hundreds that you used to turn these decimals into a whole number. If you're feeling confident, you could say, well, I multiplied by 10 twice, and 10 times 10 is 100. So I could just do 96 divided by 100 in order to reach the correct answer as well. So I'm going to go on to my next slide here, where I've given you a number of sample questions that you can have a go at. What I'd like you to do is have a go at solving these questions with the video paused, then unpause the video and I'll go through my answers and how it is that I worked this out. Off you go. So then, if your video is unpaused and you are hearing me again, here's what I did in order to solve these different questions. So firstly, for 0.2, I've turned this into the number 2 because I've taken the 2 that would be in the tenths column over here and multiplied it by 10 to bring it into the ones column. I know that 2 times 14 or double 14 is going to give me the answer 28. Now, because I multiplied by 10 once up here, that means that in order to find the real answer to 0.2 times 14, I need to do the inverse and divide by 10. So if I do 28 divided by 10, where I've got my 28 up here, and I'm moving both these numbers along once, this is going to get me, so I've got my numbers 2 and 8 in the ones and tenths column, so I get the answer 2.8. I've done exactly the same thing for question B here. The difference is that if I look at 0.03 in my place value column, I've had to move the 3 twice to get it into a whole number. Or in other words, I've multiplied it by 10 twice, another way of saying I've multiplied it by 10 twice would be to say, well, 10 times 10 is 100. So, because I have multiplied by 100, in order to find the true answer to 3,200 divided by 0.03, I need to do my inverse and divide my answer of 9,600 by 100. As a result, I get the number 96. Now, have a look at question C and see if you can write down an explanation of why it is that I've done these workings out. Pause the video, write down your answer, and then unpause the video and see if your written answer is the same as mine. Here's my answer then. I know that if I do 5.4 multiplied by 10, that's going to get me the number 54. Similarly, if I do 0.8 multiplied by 10, that's going to get me the number 8. I can now do 54 multiplied by 8, which, with my workings down here, gets me the number 432. Because I multiplied by 10 twice, and I know that 10 times 10 is the same as 100, I need to do the inverse to find out what the answer to this decimal multiplication would be. As a result, I do 432 divided by 100. If I put that into a very quick place value table, and then I'm going to divide this by 100, so I'm going to move my 4 2 places over to the units. I'm going to move my 3 2 places over, so it's in the tenths column. I'm going to move my 2 2 places over, so it's now in the hundredths column, and bring down my decimal points here. I can see that I'm going to get the number 4.32. You can have a go at this with as many different decimal numbers as you like. You can make up your own, have a go at solving the questions, and then check it on a calculator to see if you've gotten the correct answer or not. That's a really good way to practice doing questions like this. Once you've had a go at doing it a few times over, it becomes far less daunting, and actually it's just as easy as doing any standard piece of column multiplication. I hope this has been helpful and that you're going to be able to use this plenty when you're doing your work in the future. Have fun with it, and I'll speak to you again soon. Bye!